Hello and welcome to this course where you are getting hands-on experience of using Docker on the real working system. Docker is one of the hottest topic right now. And if you are a Java developer and you want to start to learn Docker, then this is a course for you. In this course, you are learning Docker and along with you are applying your skill on realistic application. Example, microservices based program. We keep things simple first. We are learning about images, container, networking, volumes, and we apply this concept to very basic application. This entire series is one big practical session, and if you are following me to the end of the course, you will be running real Docker container in the cloud. So stay tuned. In the next lecture, we talk about the Docker. Thanks for watching. Hi friends, Govin this side. Welcome back. This is chapter 3 where we are going to install the Docker in our machine. So to install the Docker, first we need to download it. So to download, just type download Docker. This is the official link. Click here. And I'm using Windows operating system. That's why I'm downloading for Windows. If you are using Mac or Linux, you can click here and download the Docker. So for Windows operating system, click here. Downloading is starting. Okay, so Docker is downloaded in our machine. So go to the folder. Now double click on this Docker icon. Say yes. Now installation is started. It is asking to create the shortcut on desktop, yes or not. So I want to create the shortcut of Docker on desktop. So I check the checkbox. Click on OK. Okay, so installation process is started. It will take a lot of time, so I pause the video. Once it's done, we'll continue. Okay, so we're done with the installation. So now close it and go to the desktop. See, shortcut is created. Okay. Now open the terminal and check Docker installed properly or not. So type Docker version. Here is go. So Docker version is 20.10.22 is the latest version. So we installed the Docker successfully in our machine. In next video we will play with the Docker commands. Okay. So meanwhile you can install the Docker in our machine. So thanks for watching. Hi friends, Govin this side. Welcome back. This is chapter 4 where we are going to look very important Docker terminology. Before going forward, you should know about this terminology. Okay, so let's start. So first we need to understand about the docker image. Okay, so let's first understand about the docker image. Docker image. Docker image. Okay, so what is docker image is? So docker image is a file. Okay, the docker image is a file, or we can say that it is a set of instructions. Okay, docker image is a file, or it is a set of instructions used to execute the code inside docker container. Used to execute the code inside docker container. Okay, so docker image is a file or set of instructions used to execute the code inside docker container. Okay, so if you want to execute the code inside docker container, so required some set of instructions. So that set of instructions hold by docker image. Okay, so docker image contains your application plus all the required environment to execute that application. That everything is present inside your docker image. So let's understand with diagram. So suppose this is your Springboot application. You created one Springboot application, and after that you create its docker image. This is the docker image of your Springboot application. Okay, so what docker image contains? So docker image contain your application. This is your Springboot application. So when you create the docker image of your application, so inside the image, docker image, your application is present. Plus, while creating this application, you have added some libraries. That all libraries is also present inside your docker image. To run your application, some server is required. The server also present inside the docker image. And while creating this application, if you use some other files, that other files also present inside your docker image. So basically docker image is one environment. Okay, so basically one environment to execute your application, whatever required environment, whatever environment is required, that environment is nothing but the docker image. Okay, so we can say that docker image is a set of instruction. This is a set of instruction to execute our code inside docker container. This is our code to execute our code inside docker container. The required environment, or required the set of instructions, okay, that is present inside the docker image. Now if you move this docker image on any computer, so you no need to add the extra software, you no need to install any dependency, any libraries, or you no need to set any variable path. Just move this docker image on any computer and just run. Your application is run perfectly. No need to set any environment over there. Okay, because everything is present inside your docker image. To run your application, okay, to run your application, whatever required libraries, server, or whatever environment is required, everything is present inside your docker image. Understand? So I hope you understand what is the docker image is and what docker image contains. So docker image contains the set of instructions, okay, plus your application. And while running the application inside docker container, okay, so it read that instruction and run your application inside docker container. Next, docker container. What is docker container? Okay, so docker container is nothing but the running instance of your docker image, So docker container is nothing but the running instance of your docker image. So basically docker image is run inside docker container. Okay, so docker image run inside docker container. So finally the running instance is docker container. So we can say that the docker is the running instance. Image is not running, container is running. So your image running inside container. So that's why docker container is nothing but the running instance of your docker image. You can create any number of container for same image. Okay, the key point or note. You can create any number of container for same image. Example, suppose I have a docker image 1, okay, and I run this image in in container 1. Now I want to run this Docker image in container 2, so I create container 2. I want to run this image in container 3, so I create container 3. So you can create any number of containers for same image. Okay. Next, Docker repository. Docker repository. So Docker repository is nothing but the storage. Docker repository is nothing but the storage where you can store, okay, where you can pull or push, where you can pull or push Docker images. Okay, suppose you create you create one Docker, you created some Docker image and you want to store in some on some server, so that is nothing but the Docker repository. Okay, you can push your Docker images on Docker server, and whenever you want you can pull also. Okay, so these are basically like your Facebook, you created the account on Facebook and you can upload your images on Facebook and you can download your images from Facebook. Okay, so something like that. If you want to store your Docker images on any storage, so you can push your Docker images on Docker repository. Whenever you want you can pull also, means you can download that images on your local system. Okay, so that is a Docker repository. So to pull or push Docker images on Docker repository, you need to create the account first. Okay, on Docker Hub. So let's create the account on Docker Hub. So open browser and type Docker Hub. Click on first link. Here is the option of register. Okay, so click on register and create your account, enter username, email, password and sign up. Okay, so I have already account on the Docker Hub, so let me log in first. Username or email ID and with password. So this is the home page of Docker Hub. This is the Docker repository. Okay, you can see here, this is the Docker images. I have created these Docker images and I push these Docker images into the Docker Hub. Here my images is stored. I can download or pull these images whenever I want from this repository. So this is nothing but the storage for Docker images. Okay, I hope you understand all these three terminology: Docker image, Docker container and Docker repository. If you have any doubt or any suggestion related to this video, you can ask me in comment. So in next video we'll play with the all Docker commands. Okay, so thanks for watching. Hi friends, Govin this side. Welcome back. This is the chapter 3 where we are going to install the Docker in our machine. So to install the Docker, first we need to download it. So to download, just type download Docker. This is the official link here. Downloading is starting. Okay, so Docker is downloaded in our machine. So go to the folder. Now double click on this Docker icon. Say yes and good. Now open the terminal. Hi friends, welcome back. Govin this side. This is the chapter 5 where we are going to play with some Docker commands. In last lecture we have discussed on some very important Docker terminology like what is the Docker images, what is Docker container and Docker repository. If you are the new to this channel, so I request you to watch my previous video, then only you get the better understanding on this. So let's start to play with the Docker commands. Okay, for this open terminal or command prompt. Okay, so our first command is docker version. So type docker version. Okay, this command is used to get the currently installed version of Docker. So currently this version is installed in my machine. So if you want to check the Docker version in your system, so type docker version command. Now I want to check the list of Docker images present in my system. I want to see the list of Docker images present in my system. So for that, command is docker images. Okay, press enter. So currently there is no Docker image present in my system. Okay. Next command is docker pull command. Docker pull. In last lecture we heard something about the pull. Okay, so docker pull command pull the Docker image from the Docker hub. Okay, so docker we need to pass the image name to this command. Whatever image name we pass here, that image is docker pull command download that image from the Docker hub. But the suppose for example I want to download the Python image. Okay, so now I need to pass the image name, but the problem is I don't know the image name. Then how can I pass the image name in here? Okay, so for this you need to go on Docker hub. In last lecture we have created the Docker hub account. Okay, on Docker hub account you can check the image name, what image is present on Docker hub, so and what image you want. Okay, so suppose I want the Python, so here is the name of the image. Okay, let's suppose I want to download the Ubuntu image on my local system, so docker pull command and pass the image name. Okay, so pull command first check this image is present locally or not. If this image is not present on local system, then only pull command pull the image from the Docker hub. Press enter. Now pull command pull the Docker image from the Docker hub. Okay, so image is now available in our local machine. So check by using docker images. Docker images. Now one image is present in our system. Okay, now let's run the image. So command is docker run -it-d and you need to pass the image ID. -it means interactive mode and D means detach mode. We can discuss on this later. Okay, so to run the image we need to, the command is docker run and we need to pass the image ID or image name. Okay, in last lecture we have discussed whenever you run the image, your image is run inside the container. Okay, but we have not created any container. It means whenever you run your image, so internally one container creates and in that container your image is running. So press enter and check. Okay, so one big ID is generated, that is nothing but the container ID. Okay, so one container is created and your image is running now inside that container. Okay, so now I want to check the list of running containers. So command is docker ps. So currently only one container is running, right? In last lecture we have discussed you can create any number of container for same image. Okay, let me run same command again. Again I run same command. Okay, so same image I run 3 times, so 3 container is created for the same image. Okay, so same image is running on different containers. So now check with the command docker ps. Docker ps command list out the all the running container. This is the running container and you check here the image ID, all same image running on 3 different container. Okay, clear? Next command is docker docker rm docker uh, docker exec command, docker exec. With this command we can access our running container. Okay, so docker exec run in interactive mode and pass your container id, so running container id. Okay, after that bash. So now you inside in your container. Okay, now you can access your running container. Okay, if you want to come back from your running container, just type exit. Okay, next command is rm command, stop command. Okay, so I want to stop the container. Docker stop. Okay, before stop I want to check all the list of container present in my system. Okay, so docker ps command display only the list of container which is running. Okay, only the running container, but I want to see all the container list. So -a docker ps -a display all the list of containers, right? Now stop one container, docker stop container id. Okay, now one container stopping. Once this container is stopped, after that we check the difference between uh, docker ps and docker ps -a. Okay, now run the docker ps. So docker ps return only list of running container, so only 2 container is running. Now type docker ps -a, 3 container is present in my system. Out of 3, 2 container is running. Okay, now stop one more container, stop this second container, docker stop. Okay, docker stop, it will take some time because it first stop the container gracefully and then remove from the queue. So the stop command takes some time to stop the container, right? To stop the container, we have one more command, docker kill command. Docker kill command. When you use kill command, so your container stop immediately. Okay, press enter. You understood? So to stop the container, there is 2 commands. One is stop command and other is kill command. Okay, and the difference is kill means command kill the container by stopping its execution immediately. Okay, kill command stop the container immediately. The difference between docker kill and docker stop is that docker stop gives the container time to shut down gracefully. In the situation when it's taking too much time to stop, then that time we use the kill command, kill our container, right? So now check the running container, docker with ps. There is no running container at all. We stop all the container. Okay, type docker -a. There is a docker ps -a. There is total 3 container. Sorry, docker ps -a. Okay, so there are total 3 container present. No container is running at all. Okay, let me start one container, docker start and container id. Okay, now I want to remove one container. Okay, so command is docker rm. Okay, and pass container id. Okay, and press enter. Okay, so this container you cannot remove because this is the running container. If you want to remove the container, then you need to stop first. Okay, so let's try with some other container. This container is not running. Okay, so pass the container id and press enter. This container is removed from the system. Okay, try one more, docker okay, now check docker ps -a, only one container present in our system. Okay, docker ps running container also one, all container also one, right? Next command is docker rmi command. Okay, docker rmi command. Docker rmi command used to remove the image from local system. So first check the list of images with docker images command. Only one image present in our system. Now remove that image using docker rmi command and pass the image id. If you try to remove this, it unable to remove the image. Why? Because this image is using one container. Okay, it means we need to delete that container first. So open docker ps, that is the running container. Okay, so first we stop the container, docker stop or directly kill. It will take some, it will immediately terminate, that's why kill, and kill the terminal. Okay, I kill the terminal. I have not removed the I have killed the container. I have not removed the container, just kill container. Okay, now if I try to remove the image with the docker rmi and pass the image name, okay, or image id, we are unable to delete the image. Okay, it means your container is running state or a stop state. Okay, but if your container is using image, then you cannot delete it. Okay, you need to delete container first, then only you can delete the image. So delete the container, docker rm, and pass your container id. Okay, now I delete the container. Now you can delete the image, docker rmi. Okay, your image is deleted now. Now check docker images. There is no image at all in your machine. Now check docker ps running container. There is no running container. Check docker ps -a means all container. There is no container in your system right now. Okay. Okay, so if you have any doubt or any suggestion in this video, so you can ask me in comment. Okay, so in next video we create the we look into some new commands like build command, push command. Okay, we create the Springboot application and we create our image of our application, and we will push our image on the Docker Hub. Okay, we will see all these things in next lecture. Okay, so thanks for watching. Welcome back. Go in this side. This is the chapter 6 where we are going to learn about Dockerfile. In last lecture we have played with some Docker commands. In this lecture we want to create our own Docker image. So before creating the Docker image we should know about the Dockerfile. So Dockerfile is a simple text file in which we write some instructions. Docker read the instructions from Dockerfile and create the Docker image. And from Docker image we can create the Docker container. Okay, so Dockerfile is the default name. It always starts with capital D. In this Dockerfile we write some instructions, some commands, and Docker read the instructions from this Dockerfile and create the Docker image for us. And from Docker image we create the Docker container. This is a simple flow. Okay, so let's create the Dockerfile first. Okay, so but before this we need to understand some instructions. Okay, so let's understand. This is a 4 instructions. First is from, second copy and add, third is expose, and fourth is entry point. So first is from. From is the first instruction in Dockerfile. Okay, it is the first instruction in Dockerfile. With this instruction Docker creates the base image. Okay, suppose you give the image name from ABC, so Docker creates the base image as ABC, right? Second, copy or add. So in this command we pass 2 parameters, source and destination. Okay, if you are using the copy, then in source we can pass file name or folder name only. But if you use add, so in case of add, in source you can pass file name, folder name, or any URL. Okay, that is the difference between copy and add. In destination you need to pass the image name. Third is expose. In expose you need to pass the port number. For example, if you want to expose your application on some port number, so you can pass port number on expose. Fourth is entry point. Entry point is nothing but your entry point of your application. In Docker image there is a lot of things is present. So when you run your image, so you need to tell the Docker, oh boss, this is my entry point, you start from there, right? Like when you create any Java application, so main class is your entry point. Same in Docker, you need to tell the Docker, boss, this is my entry point, you first start from there. Okay, so this is 4 instruction is very important to create the Docker file. So after learning this instruction, your Docker file looks like this. Okay, so from OpenJDK 8 JDK Alpine, this is my base image. I expose my application on port number 8080. I use add. In add, this is my source and this is my destination. My application present in target folder, so I pass this path, source path, and in destination you can pass anything. Okay, so I pass the jar name, my source jar name, and that jar name which is present in Docker image, that jar name. Both I take the same. Okay, you can change also, means this is my jar name and I want the jar name inside image something like app1, so you can change also. This is the entry point. In entry point I pass the command to run my application. So java -jar and this image name. This name is passed here, not this name. Okay, suppose I create here app1. It means inside your image there is a application name is app1.jar. So in entry point I need to pass the app1. Okay, in this case I keep the source jar and the jar which is present inside image, both are same, so that's why I pass here app.jar. So you need to create the first docker file like this. Once you create the docker file and build your application, after that you can easily create the docker image. Okay, so how to create the docker image by using docker file we can see in the next lecture. If you have any doubt or any suggestion in this video, you can ask me in comment. So thanks for watching. Friends, welcome back. This is the chapter 7 where we are going to look how to create the docker image of our Springboot application. In my last lecture I discussed on docker file, what is the docker file is and how docker is read the instruction from docker file and create the docker image for us. Okay, if you are the new to this channel, so I request you to go and watch my previous videos, then only you get the better understanding of this. So let's start. First we create the Springboot application and then we create the docker image of our Springboot application, and finally we push the created image onto the Docker hub. So let's create first Springboot application. File, new, Spring startup project. Here the application name, I give name docker app. Click on next, select only one dependency, Spring Web. Click on next and finish. Add one controller here. Make it as REST controller. Add one endpoint. @get mapping, and you can access these by using /any_name data. Okay, so our application is ready. Now in last lecture we have discussed how docker create the docker image. Okay, so docker read the instructions from docker file and create the image. Okay, it means we need to add the docker file in our application. So right click in project and add docker file. D is always capital. Okay, finish. Now we need to add the instruction in docker file so that docker read this instruction from docker file and create the docker image of our application. So in last lecture we discussed about this instruction, what is the meaning of from, what is the expose, add and entry point. Okay, so here app.jar, so let's go to the pom.xml and add one tag, final name. Okay, final name is docker app. Okay, docker app. Okay, it means when I build my application, so jar is created under target folder with the name docker app. So go to the docker file and change here and write docker app. Okay, here you can give any name. Okay, so I give docker app img something to differentiate. Okay, so inside docker image the jar name is docker img, and you need to tell the docker boss start the application from this jar. Okay, that's it. So we have created docker file and we write the some instruction. Now the docker read this instruction and created the docker image for us. So let's first build the application. Right click, run as, maven build, clean, install. Okay, so inside target folder docker app.jar is created. Okay, docker app.jar. So I add this docker app.jar in docker image with the name docker app img. Right, let's open the command prompt. First we check the existing images present in our local system, docker images. Okay, so currently there is no local images present in our system, so let's create the docker image of our application, docker build. Okay, with this command we can create the docker image of our application. Here we need to pass the path of docker file. In last lecture we have discussed docker read the instruction from docker file and create the docker image. Okay, so that's why we need to pass the path of docker file. So here is our docker file, so copy this path and paste here. So with this command docker enter into this directory. Okay, docker enter into this directory and read this docker file instruction and creates the docker image for us. Press enter. Okay, so now check docker images. Here docker image is created. Now assign some name to our docker image. So docker tag image name and Springboot app img. This name I want to give to this image. Okay, colon, I want to give some tag latest. Okay, press enter. Docker images. Okay, now you can see that here this is your image ID and this is your image name. Now let's run the application. Docker run. Here your Springboot application is up and running on port number 8080. So now open the web browser and type localhost :8080/data. Oops, we are not getting any response from the server. So open terminal. Okay, so docker images. Okay, so now run the application on some different port number. Docker run -p. Now I want to expose the default port number onto some another port number. For example, 1990:8080. So this 8080 port number is my default port number which I assign to my application. Now I want to expose this port number to some another port number. Okay, and this is my application, means image. Enter. Now your application is running on port number 8080, but you expose it on port number 9090. So go to the browser and instead of 8080 just type 9090. Okay, here is the response. Going this side, welcome back. This is chapter 12 where we are going to look how to create a reusable docker file. Once we create the docker file, we can reuse in any other project. Okay, so let's start. So this is our project we have created in last lecture. So if you are new to this channel, then I request you to go and watch my previous video so that you can get a better understanding on this. So this is a docker file which we have added in our project, and this is the instruction. Okay, so we already discussed on this the meaning of this instruction and why we add this instruction in docker file. Okay, so suppose this docker file we added for this project, and now if I create one more Springboot application, so for that I need to create one more docker file, and I need to change this name, target demo, this target demo, here this docker demo, and this docker demo. I need to change 3 names. Okay, why? Because in this project I give here static name. Okay, inside target folder there is a docker.demo.jar. Okay, so that jar I want to copy in the image file. Okay, so for some other project, for example, if I create the test project, so inside target folder there is a test.jar, so copy test.jar. So this need to replace each time. So now my requirement is I want to create this very generic file. Okay, so instead of static name, just add star. So star.jar, it means in target folder whatever name of jar, whatever name .jar. Okay, so from target folder docker copy this .jar file into the image file. Here give generic name app.jar. Okay, so inside target folder whatever name of jar is copied into your app.jar. Now this app.jar present inside image, so entry point should be app.jar. Here now we need to pass slash at the end. Now let's create the build. This is our generic docker file. You can copy this file in any other project. For every project this file work. Okay, so let's run and go to the maven build and now we are using this command. Okay, why we are using this command? This is not related to this generic docker file concept. If you don't know about this command, so watch my previous video. With this command, application build, your docker image create, and your docker image will be pushed on your docker hub. 3-step perform with this command. So that's why I add this command. If you don't know about this, you can watch previous video. Okay, push and now go to terminal. Here you can see build is created. Now image creation started. Okay, step 1 out of 4, step 2, 3, 4. Okay, image created and your docker file pushing into the docker hub. So let's see what is the docker file name. In pom.xml docker file name is docker generic image. Okay, so pushing mounted from docker hub, some mounting is okay, push. Now go to the docker hub and check dockerhub.com, sorry, docker hub. Okay, in docker hub we have just pushed our image, docker generic image. Okay, this is the name, docker generic image. You can see here in pom.xml we create the image with name docker generic image. Okay, so basically if we add this type of configuration in our docker file, so this is the generic docker file. Okay, you can use this docker file in any other project also. No need to change anything from here. Don't forget to add slash after that. Okay, if you provide the static name here, okay, for example, if you provide the static name, okay, then you don't no need to provide a slash here at the end. But star means more than one jar, there may be chance more than one jar file is present, so that's why we need to add slash. Okay, so thanks for watching. If you have any suggestion or any doubt, please ask me in comment. Bye bye. Hi friends, welcome back. Govind this side. This is chapter 8 where we are going to look how to deploy multiple Springboot microservices to Docker using Docker networking. In previous lecture, we saw how to deploy single Springboot microservices to Docker container. If you are new to this channel, so I request you to go and watch my previous video. Then only you get the better understanding on this concept. Suppose the requirement is such that we may need to deploy multiple microservices onto the Docker container. For example, we have two microservices, employee producer and employee consumer. As name suggested, employee producer expose the REST API which will be consumed by employee consumer. But the Docker has been designed in such a way that it should have only one single service running. So we will be deploying these two microservices on two different containers and have them interact with each other. Okay, so let's start. First we will create the employee producer microservice, then we'll create the employee consumer microservice. After that, we'll create the Docker image of employee producer and Docker image of employee consumer. Once it's done, after that we will create the network and run our two microservices on the same network. So let's create the microservices first. Employee producer, add one dependency, Spring Web. Create one more microservice, that is employee consumer. Okay, so we have created two microservices, employee producer and employee consumer. Now go to the employee producer and add one controller over here. New Java class, REST controller. Make it as the REST controller. Add one endpoint here. Public string get data. Public string get data. Return this data generated by producer. Okay, this data is generated by producer. At the get mapping, add endpoint producer data, something like that. Producer data. Okay, so you have created the one REST controller. In this you have added one endpoint. Okay, endpoint is the producer data. When you call this endpoint, this producer return the string. So let's test this. First let me change the port number. So go here, add server dot port. I assign 5000 to my producer. Okay, so let's run the producer. Okay, now your producer is up and running on port number 5000. So localhost :5000, comma producer data, right? Endpoint name is producer data. What happened? The endpoint name is /producer data. Okay, not producer data. Let's stop server and run again. Okay, run as Springboot app. Go to the browser and refresh the page. What happened? Producer data running on port number, oh, it is running on port number 8080. I provided the port number 5000, so let me do one thing. First build the project, go to the run as maven build, clean install, okay, make fresh build and then run, so that your changes is reflected properly. Okay, build is success. Now right click and run Springboot app. Okay, now check. Okay, now it is running on 5000, so go in browser and run. So this data is generated by the producer. Okay, so now this is the endpoint which is exposed by producer. Now the consumer use this endpoint, so go to the consumer and add one REST point here, REST controller. Okay, you can give any name, add the REST controller. Here add one endpoint, public string display producer data. Okay, consumer don't have any data, so consumer consume the data from producer. So for that we need to create the object of REST template. So create the object of REST template equal to new REST template. Okay, and call the REST template dot get for object and pass here the URL of producer. Okay, this is the producer URL, comma, return type is string.class. That's it. Okay, return. Here add mapping, add the get mapping, consumer data. Okay, so consumer consume the data from producer. Okay, when we call this endpoint, okay, so this method call the producer endpoint or producer data. From producer, whatever result came here, that result we will get. Okay, so let's run the application. Okay, first let me check the port number. Okay, assign port number server dot port equal to 4000. Okay, let me build first. Run as maven build, clean install. Okay, so in this consumer endpoint we add something here like consumer called. Okay, consumer called, something like this. So let's run the consumer now. Okay, so your consumer now running on port number 4000. Okay, so this producer, now localhost 4000 slash consumer data, right? Consumer called the producer API and this data generated by producer. Okay, so when we hit this URL consumer data, okay, so when we call consumer data, so consumer data call this producer API and producer generated result and we get the result. Okay, so in this way we create the two microservices, employee consumer and employee producer. Now to create the Docker image, we need to add the Docker file in this application. Okay, so let's add Docker file in both the application. New file, Docker file. Here also add new file, Docker file. Okay, now let's add the instructions in this Docker file. Okay, one second, let me see the instruction. So let's copy this instruction and paste in Docker file. This is the producer Docker file. Okay, so here I write the target slash producer. Okay, this is my jar name and I copied same on Docker image producer.jar and entry point is producer.jar. These all things we discussed in previous lecture. Okay, copy this also and paste here. Instead of producer, write consumer. Here consumer.jar. Here consumer.jar. Okay, so go to the now pom.xml and I want my jar name is producer. Okay, so in your target folder your jar is generated by producer.jar. Okay, let me stop server. Go to the pom.xml of consumer and here also pass the final name. Final name is just a short name which I want easy to use, easy to read. Final name is consumer. Okay, so now when you build your application, okay, so your the jar is generated with this name consumer and here it's producer. Let's build the application. Clean install. Okay, build is success. Here also right click and build, clean install. Okay, now refresh the application. So in target folder here consumer.jar is generated. In target folder here producer.jar is generated. Why? Because in pom.xml we pass the name producer, that's why in target folder producer.jar is generated. And in Docker file we pass same name. In target folder producer.jar is present. Okay, that jar, same jar I want in my image. In consumer.jar is present, that I want in image consumer.jar. Okay, so we added the Docker file. Now let's create the image. Okay, so to create the image, open the terminal. First we create the Docker image of employee producer microservice, then we'll create the Docker image for employee consumer microservice. So first let's check the existing images present in our local system. So Docker images. So currently there is no Docker image present in our local system. So let's create the Docker image for employee producer. Docker build Docker image build 20, and here we need to pass the image name. So I want to give image name employee producer img. Okay, you can give any name. Okay, this is my image name, and now we need to pass the path of Docker file. So for employee producer, this is a Docker file and this is the path. So copy path of Docker file and press enter now. Okay, so there is something wrong in our Docker file, so let's go in Docker file. Okay, so here we miss the comma. Go to this Docker file, here also we miss the comma, and here in producer Docker file name is not correct, so refactor rename Docker file f should be small. Okay, now let's run the same command again. Okay, so image is created for employee producer microservice. Docker images. Okay, here is one image, employee producer img. Now let's create the one more image for consumer, employee consumer img. This is my image name, and now let's pass the path of Docker file. So path of Docker file for consumer is consumer. Okay, so image is created for consumer also, so Docker images. So two images is ready, one for employee consumer microservice and one for employee producer microservice. Now let's run the producer. So docker run -p. I want to expose the default port number 5150 and name of the your image name and name of the image. Okay, enter. So now producer is running on port number 5000, but we expose on 50. So just type localhost :50/producer data. Okay, so we get the result data generated by producer. Okay, so from producer we get the data. Now let's go and run the consumer. Docker images. Okay, docker run -p. I want to expose the port number of consumer to 40, and here consumer image name. Okay, now consumer running on port number 4000 and we expose it on 40. So go and type localhost :40/consumer data. Okay, consumer data internally call the producer. So let's go in the consumer. Okay, this is the this is our consumer data API. When we hit this REST API, internally this API call the producer data. Okay, so let's check, enter. Okay, the page is not working. Why? So let's go and check. Is there any exception? So okay, okay, sorry, my mistake. I started producer. So let's open tag and docker images. Okay, docker run -p 40 : let's expose on some other port number 30:4000, and this is a consumer. Okay, let's run the consumer. Okay, now consumer is running on port number 4000. So go here and I expose 4000 to 30. So we get the exception. Now this is the connection issue. Okay, connection is refused. So We created the two Docker images, one for producer and one for consumer, and two Docker images running on two different containers. Okay, so they are unable to communicate with each other. Means when we call the consumer call the producer, but producer not responding. Okay, so they are unable to call to each other. So that's why now we need to create the one network, and in same network we need to run that both container, consumer and producer. So let's create the network now. So before creating network, first we stop the all container. Docker ps, this is our running container, so docker kill. Okay, we can kill both the container. Okay, now both container are stopped. Okay, so first type docker images. Okay, so this is your image name, producer. So copy this image name now and go to the code, and instead of localhost now replace here image name. Okay, now create the build of consumer. Meanwhile, let's delete the this consumer image. We need to create new image now because we have some changes in code. So docker ps-a, first we need to delete the container. Okay, so docker rm. Okay, docker rm, delete the consumer. Docker rm, docker rm and consumer container. Okay, so docker images, now we can delete the image, docker rmi, and delete the consumer image and create new. Okay, now let's create the new image for consumer. So docker image build -t employee consumer img, and pass the path of docker file. So for consumer, this is the path, pass docker file path. Okay, so now a new image created for consumer. Okay, so now let's create the network. Docker network ls, this is the existing network. Okay, and now command to create network is docker network create, docker network create, and network name. So I will give consumer producer. Okay, this is my network name. Now check network created or not. Okay, so here network is created, consumer producer. So we created one network. Now we run our images on this network. Means both images, producer and consumer, both images running on different container. Okay, but on same network. Okay, so just run the container, create, and directly I create the container and run the image inside it. So docker container run. Okay, docker container run. On which network you want to run this? So I want to run this on consumer producer network. So pass the network name. Okay, after that name. Okay, so in this network you want to run your image, so you can give image name here. Okay, So what name you want, what image name you want in network, that image name you need to pass here. So I want the image name as employee producer consumer, oh sorry, employee producer img, same image name I want here also. Okay, and I want to expose this on port number 50. Okay, I want to expose in port number 50. And finally we need to give the actual image name. Okay, let's understand this command. With this command I create one container. Okay, in this container I want to run this image. This is the image name I want to run in this container, and I want to run this container in this network. Okay, consumer producer network. And in this consumer producer network I want my image name as employee producer img. You can change this name. Okay, enter. Okay, so let's check what is docker container docker container docker container hyphen network. Okay, enter. Okay, so now your image is running or container is running on this network. Okay, this container is running on consumer producer network. Now let's run other image. So I want to give the image name on network is consumer. Okay, and I want to expose this on port number 30. Default port number is 4000, and actual image name is employee consumer. Okay, so now both images, consumer and producer, running on same network. Okay, so let's start. Let's check here. This is your producer. Okay, we get the data from producer. Now let's check the consumer. Okay, consumer call, this data generated by producer. Okay, now both microservices is communicate with each other. When we call consume data call the producer data, and we get this data from producer. Okay, so in this way, if you have more than one microservices, so you create the docker image of that microservices and create one network and run that all microservices in same network. In this way we can communicate the microservices to each other. Okay, we can inspect the network also here. There is a lot of network related command. Okay, if you want to inspect the your data, so there is command like docker inspect network, and you can pass the network name or network ID. Okay, so this is your network. In this network, this is the list of container. Okay, first container is running employee consumer img, and next container which is running employee producer img. This both container is running inside this network. Okay, network name is consumer producer, and inside this network these two container is running. Okay, so thanks for watching. If you have any doubt or any suggestion, you can ask me in comment. Okay, so, thank you. Friends, welcome back. Going this side, this is the chapter 15 where we are going to look how to deploy multiple Springboot microservices using Docker-Compose. So in our previous video we saw how to deploy multiple Springboot microservices to Docker container using Docker networking. Okay, but previously we had do the uh, some step manually, like we have created the Docker network manually. After that we start that container manually and deploy our images on that container. That all three steps we did manually in our previous example. Okay, so that step now will do automatically by using docker compose. Okay, compose is a tool for defining and running the multiple container docker applications. With compose you use a YAML file to configure your application service. Okay, so basically here we need to create the docker compose YAML file, and with only one command we can achieve the microservices communication in docker container. So let's start. So this is my two microservices. One is consumer microservice and other is producer microservice. Okay, so in producer microservice I have created only one controller. Here is one test controller. Okay, and get mapping of data, and this is the data produced by producer one endpoint. Same in consumer, we have created one controller, test controller, get mapping, see data, and this consumer calling the producer microservice. Okay, so this is a producer microservice. Okay, so we have created two microservices. Okay, all these things we already discussed in our previous video. If you are new to this channel, so I request you to go and watch my previous video. Okay, so this is a simple two microservices, and in both microservices we add one docker file. Okay, here one docker file for consumer. Okay, and here is another docker file for producer. Okay, to create the docker image we create the docker file. Okay, after that we create the docker image by using this command, docker image build -t. So I have created the two docker image. One is employee consumer and other is employee producer. Two docker image I have created. Okay, and now come to the point on docker compose. So now we have created one docker compose file. Okay, so in this docker compose file, first here we give a name services. So two services, consumer service and producer service. You can give any name here. Okay, doesn't matter, whatever name you want to give, you give any name. After that image. Okay, so I have created the image name employee consumer, employee producer. You can see here there is a image name employee consumer, same employee producer. So I have created two images, employee producer and employee consumer. So I have provided image name and container name. So you can give any container name, whatever you want. You can give container name, means that container run inside your network with this name. So you can give container name whatever you want. Okay, and here is a main important is network. So the here is a network. Okay, so this is simple YAML file I have created. Okay, now you can keep this YAML file anywhere inside your system. Okay, anywhere. So I have kept in some E drive. Okay, so now on this location I have just type one command, docker compose up. Okay, with this command container is created. Okay, this container is created, two container is created, and two container running inside this network also created. Container also first two container created, employee consumer C, employee consumer P, two container created, and these two container running inside consumer producer net. Okay, so I have not did any step manually. Okay, network created automatically, container created and container started automatically inside that network. Okay, so with the docker compose we can easily achieve the microservices communication inside docker. Okay, so if you have any doubt or any suggestion related to this video, you can ask me in comment. Okay, thanks for watching. Hi friends, Govind this side, and in this video we will see how to deploy the Springboot var file on Docker. Okay, so basically deploying a Java var in Docker container. This is our topic. Okay, so in our previous video we have created the jar files, and that jar file we have deploy on Docker container, and or we can say that we run that jar file on our Docker container. Okay, but now in this video we will going to create the var file, and that var file we are deploying in Docker container. Okay, so for this let's create the first Spring Boot application with var packaging. So Spring Boot applications, okay, var demo example, var demo, just say next, just add one dependency, Spring Web. Okay, no other dependency required. Okay, so first go into pom.xml, and here add packaging tag. So which packaging you required? Var. Okay, when you build your application extension should be var, so packaging name is var, and I want application name something like so give here final name, and here application name like demo. Okay, demo, or something like test. Okay, something like test is my application name. So when I build my application, so my application is created inside target folder with name test, and packaging is var, so test.var, final name is test. Okay, so this is one change, and second change is you need to go to the main class, and main class we need to extend with Spring Boot servlet, extends with Spring Boot servlet initializer. Okay, to make our var file as a deployable, for this we required this class, means we need to extend this class to make our var file as a deployable, and for this we need to override the configure method, and in this configure method just remove this and just pass here builder dot source, and in this source class pass our bootstrap class name. Okay, this is our bootstrap class. That's it. Okay, so these two major changes required. Okay, that's it. Now let's first build our application once to check proper var file created or not, then we create the Docker file. Okay, so run as maven build clean install. Okay, okay, so now go to the target folder, inside target folder check, just refresh once. Okay, so inside target folder our test.var file is created. Okay, so this test is our final name, and we give packaging as var, so test.var file is created. Okay, var file is created, that's cool. Okay, now let's create the Docker file. Okay, Docker file is a list of command that we want the Docker engine to execute. Okay, means Docker read the instructions from Docker file and create the Docker image for us. So let's create the Docker file. So right click, new file, D capital. Okay, standard name Docker file. Okay, so this is a Docker file. In previous video we passed base image as Java JDK to our Docker file. Okay, but in this example our base image is not a JDK, our base image is a Tomcat. Okay, so go to our Docker file. Okay, and our image name is, just let me copy this first, here. Okay, so instead of JDK, here base image is Tomcat. Okay, we require Tomcat inside our container first, so base image is Tomcat. Cool. Okay, after that let me remove these two lines, not required now. Okay, so with this line I am adding Tomcat in my container. Okay, So let's build let's create the image with this information only. Okay, after that we deploy our war file in our Tomcat. So first let's run this inside our Tomcat. Okay, so basically what we are doing, we are adding this Tomcat in our container. Okay, with this two line, what is the meaning of this two line? We adding our means external Tomcat into our container. So let's go to the folder structure. Okay, this is war demo. Go inside war demo. Here is our docker file. So open terminal from here and create the build. Okay, so command to create the build is docker image build -t and image name, give me a demo img is my image name. Okay, and what is the docker file? Where is your docker file? In current directory. So that's why I'm passing dot only. Okay, it means current directory, this directory. Okay, press enter. Okay, here you can see your docker image started. So docker image created. Now press docker images and check docker file created or not. Docker images. Okay, right. Okay, so here is, you can see docker images. It will take some time, that's why I'm open other. So this is docker image. What is demo.img? This we have created. Okay, why 4 years ago? Okay, because why 4 years ago? Because inside this we had downloaded this Tomcat. Okay, Tomcat image, that is a 4 years ago, that's why. Okay, so this demo emg, we just have created demo-img. Okay, demo-img. So now let's go inside the demo.img or run this demo.img. Okay, so docker run run in detach mode if you want demo.img. Okay, so do one thing again. Let's check logs. Docker logs and container ID 5 digit is sufficient. Okay, let's check logs. Here our Catalina server means our server is startup. Okay, so default port number of this server is 8080. So you can go and check. Okay, localhost 8080. Okay, so you can see here we get the localhost 8080. Correct. So inside our container we integrate Tomcat successfully. Okay, now if you try to now add some external okay, now go to the application. Now add here one controller so that we can check application running properly or not. Test app. In this test app, let me add one REST controller. We have not deployed 8 our application inside the Tomcat. Okay, so let me add one controller and one endpoint. Public string get data. Okay, in this let me add get mapping data, something like this, and return h1 tag deployed file successfully, something like this. You can provide any message. Okay, now come here and go inside container now. So docker ps. So this is our running container demo img. Now go inside this container to check where we want to deploy. Okay, so inside container docker exec hyphen interactive mode or hyphen t. Go inside this container /bin /bash. Okay, what is the command? Docker ls. Okay, now you are inside container, so we just check the path. Okay, so this is a web app. Okay, but we have just inside container we have added the tomcat. So okay, this is a web app, so go inside the web app. Okay, ls. Okay, inside web app, so this is the path where we need to deploy our var file as a root.var. Okay, so pwd, let me check the path is user local tomcat and web app. Okay, now go to our docker.file. Okay, now add these two files. So now let's understand this meaning of this file. So with this we added the external tomcat into our container. Okay, what is the meaning of this line? So rm-rf means we are going to remove all the files from this folder, web apps folder. Okay, we remove all the files from this folder. Okay, and we are copying this file, which this page.var file into which location? Into web apps location. And what name? root.var file. Okay, and we run our server. Okay, so now let's create the new image with this information. So docker read this information and deploy our application inside this server. So exit this and forget this. Okay, now let's create the fresh image. So docker image. Okay, one second, let me build the application once again, because I have added the one class here, test.app. so let me build the application once. Clean install. Docker image build -d image name demo new img. Demo new img is something I give image name. Okay, and here is okay. So image. Okay, image is created. Now go and check docker images. Okay, docker images. Okay, so demo new. Okay, demo new img, this image is created. Okay, right, now do one thing. Now let's run this. Docker run demo img. Okay, docker run demo img. Okay, okay, our application is started on port number 8080. Now go and check localhost 8080 / what is our endpoint name? Data. Okay, so we get something like this, but we expected deployed file successfully, but we get this something. What is our output? We get something like this. Okay, so let's expose the port number now. Okay, so let me new docker ps. Let me stop the running container. Docker kill. This is the running container. Let me stop. Okay, docker kill. Okay, docker run docker images. Okay, so now run docker docker run -p, and I want to expose the port number 8080, which is default port number. I want to expose it to 90, and now pass your image name. Okay, just minor change we made here. Okay, now our application is up and running on port number 8080, but we expose this on 90. So instead of 8080, now just try with 90. Okay, here is our application deployed file successfully. Okay, so in this way we can deploy our file in the Docker container. So let's understand. First we have create one Springboot application in pom.xml. Here we add the packaging var and one minor changes. This is a file name, just a small name, and major change is this, means in our main class we extend with Springboot Servlet initializer and configure our class, and this is a Docker file. Okay, so this is the base image for var. This is very important, and before copying, we removing all the files from this web apps folder, and in this web apps folder we deploy the var file, copy the var file, and run catlino.sh. Okay, so thanks for watching. If you have any doubt or suggestion related to this video, you can ask me in comment. Bye bye. Hi friends, welcome back. Govind this side, and this is a chapter 9 where we are going to look how to use MySQL Server as a Docker image. If you are new to this channel, then I request you to go and watch my previous videos so that you can get the better understanding on this. Okay, so do you want to run the MySQL Server on your local machine? So how do you install the MySQL Server in your local machine? Okay, I can go to the traditional approach where I can download the MySQL installer. Okay, I can download the MySQL installer, then I can install the MySQL Server on my local machine. But as a modern developer, the approach is a little bit different. Why don't we use the Docker to run MySQL on local machine? So let's find the MySQL image on the Docker Hub. Okay, so this is a Docker Hub, and this is the MySQL image. Okay, so let's pull this image on your local system and to install. Okay, so open terminal, the command prompt, and to pull the image the command is docker pull, but instead of pull here we use the docker run MySQL 5.7. I want to download this version 5.7. If you can go on Docker Hub, there is 5.7 version is present. Okay, so you can download this version. So run command first check this image is locally present or not. If this image is locally not present, then run first, means Docker first download the image from the Docker Hub and then run. Okay, so let's check. First it checking the means image present locally or not. So unable to find the image locally, so now downloading the image from the Docker Hub. After that installation is started automatically. Okay, installation is completed, but we get the error message like okay, now we need to set the root password. So run command again and set the root password here. MySQL root password -e, that is the environmental variable, is equal to password. Okay, and here I add the detach mode -d. Okay, so I add the -d. -d is the detach mode. It starting the container on, and terminal will be ready for you. Otherwise what happened, whenever you close the terminal, your container also kill if you not add the detach mode. Okay, I added detach mode so that if I close the terminal, my container is running. Okay, so that's why I added detach mode. Press enter. Okay, so now our MySQL server is up and running inside this container. Okay, inside this container MySQL image is up and running. So how to check? Docker images. Okay, so in Docker images, this is our image and the container Docker yes. Okay, so you can see that this is our container ID, and in this container ID this MySQL image is running, right? Okay, so let's connect with the MySQL server now. Okay, so how to connect with the MySQL server? There is two options. You can use the bash shell. Okay, you can use the bash shell, or you can use this normal terminal. So command is docker exec. Okay, docker exec -it interactive mode. Okay, and container ID. So let me find out the container ID. So docker yes. Okay, now use docker exe means we can access our container by using this command. This command I explained in my previous videos. id and id of your container. Okay, this is id of your container. MySQL -u root and -p, and now it is asking for password. So password I said perfect, so this is the password. Enter. Okay, MySQL is up and running. Show tables. What is the command? Okay, so no database is selected. Create create database. Create database user db. Okay, syntax error. How to create database here? create database. Spelling mistake. Create database. Okay, now show database says something like this. Okay, so here user db database is present. Now create table emp or user id integer name character. Okay, or name text. Okay, we need to select the database. Use user db. You have SQL syntax error. You have error SQL syntax. The manual correspond to your MySQL version. For the syntax to use use user db. Okay, now we inside the user db database. So let's create the command create table. Okay, table is created. Now show tables inside user db. Okay, this user table. Now insert one row. Insert into user table. Insert value in comma in insert into user values. Now select star from user table. Okay, so in this way we can work with the MySQL. Okay, so thanks for watching, and we will meet you in next video. Hi friends, welcome back. Going this side. This is a chapter 10 where we are going to look how to create the Docker image by using Apache Maven or by using Maven command. In our previous video, we have created the Docker image by using Dockerfile and some Docker commands. But in this video, we will create the Docker image by using Maven commands. So to achieve this, we require the Spotify plugin. Okay, we need to add the Spotify plugin in our pom.xml file, and then just by hitting one command, we can create the Docker image of our application. Before going forward, if you are new to these channels, then I request you to go and watch my previous videos so that you can get the better understanding on this. So let's start. So this is my Springboot application. This is very simple application where I have created the one REST controller and one endpoint. Okay, this is endpoint, and I have added one Docker file. Here we added some configuration. Okay, so to create the Docker image, Docker read this Docker pen and create the Docker image for us. These all things I already explained in my previous video. Okay, so in this video our requirement is like, by using Maven command we want to generate the Docker image. So for that we need to add the Spotify plugin in pom.xml. So before adding a Spotify plugin in pom.xml, our jar name is docker-demo.jar. So go to pom.xml, we want the jar name pom.xml, so add final name is this. Okay, docker-demo.jar. I want final name because I added here. In target folder, docker-demo.jar will be create, and that docker-demo.jar we copied in our image. Okay, so now add Spotify plugin. This is my blog. In this blog I write the plugin information, so copy this plugin. Okay, I also give in the description block, don't worry. So open the pom.xml now. In the pom.xml, inside plugins, okay, inside plugins, copy our plugin. Okay, so this is a Spotify plugin we add. This is a Spotify plugin version 13, and this is the goals. We don't want this goal because I don't want to push that image into the Docker Hub repository, so I remove this goal. And after that, repository name, you can give any name. Okay, so I want docker demo img, something like this. Okay, so this is my image name and this is my username of my Docker Hub repository. Okay, so our image will be create by using this name. So, and this is a tag, so tag is just version, I give 1, and plugins 2 times, so I remove one plugin. Okay, that's it. Now let's run the application. Maven build, and to run the application the command is package docker file build. Okay, with this command, this is a Maven command, and with this command we can create the Docker image. Okay, so apply and run. Okay, so build is starting. Build is started, and here our build is generated. Now you can see our whatever information we wrote in the Docker file, that all the steps is started. Okay, step number 1 from JDK, step number 2 expose, step number 3 add, and step number 4 entry point. You can see Docker file. Okay, there is a Docker file. Step number 1 from expose, add, and entry point. And now go to the console and check. Okay, from, add, entry point, this is all 4 steps. Okay, here done, and our Docker image is generated. This is the name of image, docker demo img. Okay, same name we gave in pom.xml, and this is a tag. Okay, so go pom.xml and just check. Okay, this is our image name, docker-demo.img. Now open terminal and check the image generated properly or not. Just type docker images. Okay, so here is our image, docker-demo.img, and this is a tag one. So let's run it, docker run, and pass your image name. Okay, so your Springboot application is starting and up and running on port number 8080. Okay, so let's run localhost :8080 / our endpoint name is data, right? What happened? What is our endpoint name? Endpoint name is data, right? So what happened? Let's do one thing. Open new terminal and write docker images. Okay, let's run again. Docker run. I want to run this image. Okay, and I expose port number onto 8080 like this, something. Docker run -p for port number. Spelling mistake right here, docker. Okay, our application is up and running on port number 8080, and we expose port 80 here. So let's go and type here 80 and check the image working properly or not. Okay, so here image working properly, image created by Spotify plugin. This is the response getting from server. You can check here, image created by Spotify plugin. Okay, so in this way we can create the a Docker image by using Spotify plugin. Okay, this plugin information I can give in description block, and also you can go on my this blog exotic.blogspot.in. From here you get this information. Okay, so thanks for watching. We will meet you in next video. Friends, Govind this side. Welcome back. This is chapter 11, where we are going to look more about Spotify plugin. In our last video, we have discussed on Spotify plugin. We add the Spotify plugin in our form.xml and create the Docker image of our application. In this video, we want to create the build of our application and then its Docker image. Also, we want to push the Docker image into the Docker hub. So all the three tasks will do with only one single Maven command. Okay, this is the command. With this single command, we will create the build of our application and its Docker image, and the Docker image will push into the Docker Hub repository. Okay, so how do we achieve this? So let's start. Okay, so before going forward, if you are new to this channel, so I request you to go and watch my previous video. Then only you get the better understanding on this. Okay, so this is a simple Springboot application containing one Docker file. Okay, this is normal Docker configuration. Docker did this configuration and create Docker file as docker demo.jar. This is our application name. When I build this application, the jar is created inside target folder. Okay, so now we need to add Spotify plugin in form.xml. Okay, in last video also we add to just one goal. Okay, and goal is to create the image. But today we have two goals. We want to create the image and want to push that image onto the Docker Hub. So this is my blog where I added the plugin, so you can copy from here. Also I have given description section. Okay, so copy this, and inside plugins there is already one plugin, and add this Spotify plugin. Okay, there is plugins 2 times, so remove one. Okay, so let's understand. So this is Spotify plugin having the version 1.4.13, and the goal is build. Okay, we want to build the application, and second goal is we want to push our application onto the Docker Hub. That's why two goals, build and push. Okay, in last video we had only one goal, build, but in this video we had two goals because we want to push our application onto the Docker Hub repository. Next, here you want to pass your username of a Docker Hub. Okay, so hard. Okay, so this is the username of my Docker Hub repository, and here you need to pass any name of image name. So image name I will give Docker demo image. Okay, Docker demo image is my image name, and here I pass the tag as latest. Okay, this is the important tag. In this tag, user maven setting for auth true. Okay, so what is this? So with this tag, docker check in the setting.xml file where credential available or not, means your docker up credential check in setting.xml file. So let's create the setting.xml file inside the m2 folder. So go here m2 folder inside your C drive. So go C drive, users, inside users there is a m2 folder. Inside the m2 folder create one file. Okay, and this file is settings.xml file. Okay, and here you need to add your docker up credentials. So now our docker up credential, this is the XML file format, so this is nothing new. Okay, copy this and paste here. Okay, so this is the server information. Docker IO is the docker hub URL, username. Here you need to pass the username, and here you need to pass the password of your docker hub repository. Okay, so this is my username. On docker hub I have already created the account. Hardcoder Baba, this is a username which I pass here. Okay, and this is the password. Okay, next this is just a plugin name. Okay, so file, save as, file, save, setting.xml. Okay, let's check. Okay, now go to the Windows preferences. From here just go to the user maven. Inside maven user setting, and here you need to pass the maven setting.xml path. Okay, so browse. So here our C drive users RKNC m2 folder setting.xml. Select this, apply. Okay, yes. And there is one more menu, installations. In installation we need to pass the maven path. Okay, so maven path is on C drive software. There is my maven is present. I will show you. No, on E drive. Okay, so E drive, go in software, and this is Apache maven. Okay, so this path you need to pass in your installations. Okay, apply and close. And now let's go run maven build, and here you need to pass that single command. Okay, now this single command will create the build image and push that application onto the docker hub. So just paste, apply and run. Build is done. Now this all the 4 step is done. Okay, this image creation started. Okay, this 4 step from add entry point, this all 4 step. Okay, 4 step done, image creation done. Now image pushing started. Okay, emoji is pushed. Okay, image is pushed. Hardcoder Baba demo. Okay, so let's check what is our image name. Let's go to pom.xml and first check the image name. What is docker demo image? So go into the docker up. This is docker up repository. Okay, just refresh page. Here is docker demo image. Okay, docker demo image push onto the docker up repository. Okay, so with this single command, this console. Okay, with this single command our application build is created. After that image is creation. Okay, this is the 4th step where image is created, and after that this image pushed onto the docker hub. Okay, so these all tasks done with only single command. In our previous video we have created the build first, then its docker image, and this push. We have